Sridhar Rajagopal, Ennoia Technologies. Happy to talk today about AI Copilots for wireless IoT, and thank you for the invitation. So, just to give a background on the company, we started the company, me and my co-founder, we both worked together at Samsung and Ennoia, so we've been working together for 10 years. A lot of experience in the industry in different positions, worked with a lot of different customers. The focus has been mostly on the hardware and software kind of coexistence and integration development, mostly towards wireless technologies, and specifically on radios and DSP signal processing type of architectures. And our focus has been in this company to make AI understand the devices and equipment that are at the edge of the network, rather than focusing on what happens in the cloud part. And I will tell you what the distinctions are and what the trade-offs are in this. To introduce the topic, I think what I would say is wireless networks are complex, and there are so many different technologies. I mean, there is cellular, there's Wi-Fi, there's Bluetooth, there's satellite, radar, and I was just talking to John about the satellites. So, in general, what we have seen is the network complexity has been growing over time. I mean, things started something very simple, very low data rate, very low bit rates, and then keep pushing the technology, new features, new frequency bands, keep adding, complexity starts growing. So one interesting thing, again, from an IoT perspective, is if you take this self-driving car, I think they're going to introduce that in Dallas soon. But if you go to Austin, you can see some of the cars and stuff like that. I think it's very popular in Austin now. And what you would see is there are so many technologies that actually get integrated, and when the car is making a decision to turn left or right, I mean, it looks at the radar, the LiDAR that is there, it looks at, the location, it takes data from the maps, and then it's using all the sensors that are around the device. So many things that get fused, and again, as I mentioned, this thing is becoming more and more. It has to look for pedestrians, it has to look for objects, it needs to know what is stationary, it needs to know the lights. So there are so many things that actually they can make it work. So one aspect that would be of interest is also the cost of equipment and services. Now, of course, you would traditionally think that, it's IoT, it's supposed to be very small volume, small components, low cost kind of device. But what happens is when you're trying to deploy it and manage it, that's where all the cost basically comes in terms of the operation. Many times the hardware is proprietary, sometimes where you deploy it is in some remote locations, like, I'm trying to do something in a forest. The cost may be $1, but to put it where you want to put it, it may be $1,000. So again, you have to look into those type of aspects, and many times you need to know what you're doing. So it's not just have a device I can put it anywhere. Even if you buy an access point, then I'm pretty sure this hotel where they're all connected. There is some science behind how you actually put things and how you actually put it, and you pay somebody some money to actually go. It's not that you just put it anywhere and it works with the best performance. If you really want performance out of the system, you need to know what you're doing. So you need to have some expertise in that area to actually figure out how to do it. The other aspect is, again, coming to a traditional kind of cellular background. Typically, anytime you do anything on the field like that, it's actually very complex and time-consuming, especially if you're trying to debug, deploy something, try to understand what's going on. Many times after you install something in the field, if you're trying to figure out why something is not working as it is supposed to be working, you have to send somebody there, especially that could be in a remote location. You would have to collect some logs and collect some data, because the person who goes there probably doesn't have all the information he needs to debug the issue. It's the same thing. For example, in your home, sometimes the Wi-Fi router is not working, you call AT&T or whoever is that. They send somebody, sometimes he's able to fix it, sometimes he says, I don't worry about it, if they like it, and put a new one in there, but you can't do that at all places. So Where my company is focused on is looking at AI agents in the edge. So the question is, can I make somebody smarter? Like I'm a technician or I'm somebody who's trying to debug an issue, isolate an issue, understand the issue, and I don't have full knowledge, but hey, I have this AI assistant sitting next to me. Can he do all the stuff that I'm traditionally relying on an expert? Can he do that all for me? Is he trained well enough that he can assist me in my work? And so that's basically what my company is focusing on.
Can I ask a question?
Sure, but
Network operations is 20% of OpEx. How did you come about with that number?
so we did some statistics across a couple of US operators. And again, these numbers may vary based on operators. And so I'm just giving you some rough guidance based on our discussion with the operators.
Is that a non-disclosure? I think you share who the operators are.
I mean, you could think of this as an average number across operators.
It's a big number.
But it is. I mean, operator EE spends more than $100 million in all this stuff every year. A big operator.
So this is the size of an AT&T Verizon.
Yeah, so if you look at an AT&T and Verizon, they have around 75,000 to 80,000 sites in the US.
So size.
Yeah. So if you look at what is happening on the AI side with wireless, I think again there are a lot of interesting technologies now. People are looking at now. People have talked about 5G. I mean, I was involved in that from 2011 onwards. The past 15 years, I've been looking at 5G, but it has not seen the success to the extent that was promised with 5G, in my opinion. Now, of course, now people are already starting to look at 6G. I mean, there's interest in doing radar and communication together, for example, for positioning kind of application. I mean, one of the limitations that people see with camera-based positioning is it's restricted to line of sight. But for example, I want to know if somebody is walking behind that wall, and there may be some applications, for example, in defense, where I want to know if that's an enemy soldier in the corner where I can't see, and I'm able to, if I can locate that situation. Now, previously, some of the challenges with AI was that very hard to do that in a small form factor. But there has been a lot of progress on the ability to have all this locally. I mean, nowadays you can even have phones that support LLM agents. You can have ChatGPT and stuff. So not everything has to go on. And then the maturity has increased significantly in the last 2 years. I mean, you can see it going leaps and bounds in how the technology is being applied. And the costs are also reducing from the.
Can I ask a question?
Yes.
I was waiting for you to say something about AI maturity. And you have this big number, this 75%, but I can't tell anything. 75% of what is what? What's that number about?
Yeah. So I think it's talking about, I mean, this 75% is about the generative AI usage. So it's talking about the ability of AI to how the usage of AI in companies to actually do some work with the AI that has improved by 75% between 2023 and 2024.
So it's more the acceptance of AI, I guess.
That's that.
Maturity, there's still a long way.
I'm just saying that, I mean, everything is depends on what threshold you set, right? So if you look at where we were 2 years ago and we started using some of those AI tools, it would give random junk. When ChatGPT was first introduced, I mean, you ask it to spell something, it would give the wrong number of R's. If you ask how many R's are there in hemorrhage or something like that, I mean, it sometimes gives hallucinations, it would give wrong answers. So I'm saying from a technology maturity standpoint, there has been a lot of progress in what's happening today with AI.
So are you focused in generative AI? Because I was thinking originally there are other types of AI that are doing, the deep learning types of things that are doing anomaly detection, monitoring, radio.
No, I think this is just an example of AI maturity that I was saying.
All right.
It's not that I'm focused on
That's
this.
what I was wondering.
Yeah, it's just an example. So I can tell you that almost every company out there today, I mean, they are starting to look at, how AI can help with their day-to-day work and how it can actually help them write code, help them debug stuff, optimize stuff, reduce their costs, and things like that. But if you look at the IoT space, again, coming back to the topic of discussion, there's always, actually this started even from the original, sensors kind of deployment. There has always been a communication versus computation trade-off. So how much, say there is a sensor, now it is generating some data. How much should I process the data locally on that device and then send it over on the other side to kind of do the processing? So how much compute should I put versus how much communication bandwidth I should use in the device? And that has been like a fundamental discussion for a long time. And that continues with cloud versus edge type of discussion. So let's say, now you're trying to introduce AI for IoT. Now you could put something in the cloud where all the devices in the network, they send all their information to the cloud, and the cloud looks at, how to optimize this stuff, what kind of trends it's seeing. So all that can be done at a centralized location. So that's one model that we can call it as cloud AI. The other, or what I would say the more interesting or challenging part, is the edge type of AI. So what if now AI could be in every device? I think you were showing me the park that that you were moving around, taking around for gathering data. Now, wouldn't it be interesting if can I put AI in that park? Can I do something more intelligent with it? So I mean, those are the kind of questions that actually come up from an edge compute standpoint. So the way I think about it, and again, everybody has their own opinion on the maturity and validity of the technology, but the way I think about it is, my opinion is every compute in the future will have AI. If you take a processor, it will have some AI capability in it in the future. And it's just like now that processor may be sitting on a small form factor, sitting at the edge and at the device, or it could be at a data center sitting in the cloud, and that's the question of scale. But my view is at every angle, at every place, you have AI in some form or the other. And it's not that it is one or the other. It's most likely there is going to be some kind of a hybrid approach. I would do something locally at the edge to do some processing with AI, and something I would do in the cloud. And then the other aspect to consider is about the data. So AI, in order for AI to work, I mean, it needs to be trained on the data.
Yeah, and that takes incredible computing
Yes.
capability. But you just talked about putting AI on all of these edge devices. So this is an area that I don't feel like I have a good understanding in yet.
Yeah.
It's when you've got an AI model trained, can you package that in its own chip and then put it everywhere you want to?
So the way it works from a training perspective, again, there are two chains of thought here. And
Okay.
one chain of thought is you do the analysis or the actual work in the edge, but the training all happens in a centralized location in the cloud. That's one model. The other model that people
But the analysis is still being done.
the analysis is done, but the training is done in the cloud.
But the analysis is still being
Yeah.
done by the AI model, right?
That is correct, but what I mean is when you're actually running it on live data, that you don't know that it's a test data, that's the live data that you're actually doing. So that's actually being done at the edge on the device itself.
And it's not learning from that.
No, that's what I'm saying. It could collect the data, it could send it to the cloud, and then it could do something in the cloud. And then once it learns from thousands of devices, it creates like a global model of all the training it got, because I have so much data from so many devices.
Right.
And then I can push it back to the edge on the trained model. I can push it back. So that's option number one. Option number two is, again, depending on the company, there's also what they call as, I forget the name now. It's almost like a distributed model. Like you do something at the edge to process the data a little bit finer, so that you don't send everything to the cloud. You do a little bit at the edge, do some processing, and then it's like a two-stage approach. Like you do a little bit there, and then do the rest remotely.
That's what I was talking about, the anomaly detection, because I've done a lot of this in the automotive industry. And so you do a lot of the triggering on anomaly detection with AI in the vehicle, and then you only trigger on the data that you really need.
Mhm.
You don't need 95% of it or more.
That's
You don't
right.
need most of it. There's terabytes of data. So you only have to send to the cloud. So it's AI here, but it's also AI here,
That's right.
both from a training and an inferencing
Mhm.
perspective. But you have AI here doing anomaly detection.
Mhm.
So there's different use cases in different places, and that's why hybrid is really important.
Yeah.
So can I ask a question about your question?
This question.
Yeah.
It's all the same question. It's okay.
So you were talking about using AI in automotive.
Yeah.
Okay. And so in this concept of AI, so I'm sorry, I'm just I'm very nuts and bolts.
Yeah, that's good.
So if you're going to quote use AI, and I don't know what anomaly detection would mean,
Yes.
like on a CAN bus.
Yeah.
I don't understand the concept
Yeah. So
of
basically,
anomaly detection on a CAN bus.
that's where you do the training aspects. You collect a lot of data, or actually, some of these systems are now training themselves in the car. They don't have to go to the cloud sometimes. But you basically can push all the traffic in the vehicle and train models, train AI models. Most of it is down in the cloud. You train the models for the behavior.
Mhm.
AI can determine the behavior. So if you put like in regular AI, it's statistical. It'll tell you if something is a behavior that is not normal. So anomaly detection. We use it a lot in automobiles. You know, there's
Well, okay, but
dozens
see-
of models.
Oh, no. But
So
my
That's the first
question
step.
is,
Yeah.
like, I think of a CAN bus,
That's just raw data. and
yeah,
a lot of it's
but an
proprietary from that,
anomaly
so.
is like, you don't need AI to go, this isn't right.
Well, it depends what you're talking about. There's different levels of anomaly, and there's anomaly at the network level, but there's anomaly in actually the sensor data. So, say you have a certain type of sensor data. A good example: when I was at Intel at one point, we did this in industrial where we were monitoring. We had a sensor on all the motors within a factory, and you could actually sense the motor, take the vibration analysis from that, and through an AI model, determine when that model or when that thing is about to have a problem or about to go down. Because anytime you shut down something on the factory floor, it's a lot of money. So you train a model and it'll know if something's changed very slightly that a human won't even pick up on.
So maybe
Oh, yeah, well, no,
Right?
I'm
And
not.
so once you do that, that's anomaly detection. You found it. And once you know there's an anomaly, then you can send the raw data that you triggered in the buffer up to the cloud to do heavy duty processing and do it across a fleet of vehicles.
Okay, so you hit the point, exactly the point. There's this thing sensing a vibration
Yeah.
pattern.
Or CAN bus data. Which
Yeah,
is anything in the
whatever.
vehicle.
But it's sensing this variable.
Deviation of a variable,
And,
anomaly.
yeah,
or-
and so I don't get how AI is related to, okay, this variable, there's a range of values that are good, and there's a range of values that are acceptable,
Yeah.
and outside of that,
It's even way beyond that. That's just thresholding. You can do that without AI.
yeah, that's what I mean.
It's way beyond that.
No,
It
yeah,
works-
no, I know. Wait,
It works in,
AI is
in
way
the
beyond.
spectral. It works in all kinds of different areas. So
no, I think
it's almost magical in a way, actually.
Yeah.
But
So I think there are issues that can be like let's come back to the anomaly detection discussion, right? So there are issues that are easy to detect, like there's a component in the car, it failed.
thresholds and
It
binaries.
failed. I mean, you are getting data, suddenly the data stopped coming, it's all zero. I mean, that's an anomaly, but that's very easy to detect from a standpoint. Now, what makes things more interesting is, could I have predicted that this component is going to fail?
Yeah.
Because I have seen that it's over a period of time, it's actually starting to fluctuate. That's issue number one.
Component aging is a
Yeah.
big one.
So aging so that's one issue. The second issue, because I'm just looking at a certain time, I don't know what happened last week or the week before. That's one issue. The second issue is there may be issues again. depending on the context. There may be issues that are periodic, or they happen once in a while, but they don't happen all the time. So you may not be able to tell at a certain point when you're looking at the problem that there is a problem. But an AI, if it is continuously monitoring what's happening, it may not say there's a problem now, but it may say, okay, in the next hour you're going to see a problem. And I think that's where you see a lot of value that a human cannot tell precisely threshold. I think that's where a lot of predictive analytics and stuff like that with the AI is used.
And it could be like EMI, the types of things, or it could be a hacker that's trying to break in. Yeah. We also use it in security. So all the network traffic, all the canvas traffic, you can actually run that through AI also and look at traffic analysis. And so there's a 0-day threat on your vehicle from a hacker. You can identify that through AI. That's being done.
Yeah. So in my company, one of the things that we are looking at is using AI for interference detection.
EMI.
It could be EMI, it could be like an external interference, it could be, and those kind of things, they may not be predictable. You cannot tell what is happening, and it may be location specific. Oh, I'm close to an airport, I'm having an FAA radar, so that's actually generating some interference. So those kind of things, are knowing where you are for a period of time, what is happening, and these are things that are very hard to say just by looking at data. You need to know the data in the context of everything else, and I think that's where AI has a lot.
Well, thank you for being like right here.
It's an amazing area.
So I think the other interesting thing, again, I was looking at some market statistics in terms of, what are people doing in this space now. There's a hardware component to things. When they talk about, and they're calling it artificial intelligence of things. And this is mostly related to the hardware aspects. And this is more, one of the key drivers for the hardware development with AI is on the video side, because, AI has become so smart and telling cats and dogs and faces and who is there at what time. You see at security cameras, at airports, at a lot of places. And so that whole market, from a hardware standpoint, today stands at roughly around 50 million per this. But the other interesting part is, if you look at it from the use of AI in IoT, and if you look at it from a software and services perspective, that's actually, it's a $60 billion market here. And you can see the big difference between the hardware aspect and the software aspect. And this is where, the use of AI in terms of operating a network, in terms of onboarding devices, in terms of tuning the models, monitoring the data, trying to figure out what is happening, the software piece, the services piece, that's actually where a lot of money is getting spent from a ecosystem standpoint. So compared to, the hardware part, you'll see this typically in many scenarios where, just like I was saying, right, IoT, the components could be very cheap. If you take a self-driving car, for example, all the components that you need for the car, they may be cheap, but making the car work with all those components, that's where the value is, and that's what costs a lot. So I think I'll move on. I don't know, how much time do I have?
You have until 7:15, so the interaction of the question and answer session is awesome. But if we need to, we can go to 7:30.
No,
so it's up to you.
We'll try to, it's 6:30 now, but we will try to get deeper. So the other interesting thing that's happening in the AI space, and this is where I'm coming to this intent-driven model, right? So with all the AI models that people are focusing, people are saying, okay, for wireless technologies and for telecom, can I come up with a specific model? Because I don't want to know what is the capital of France. I want to know, what is the signal, what is spectrum, what is frequency. Those are the things I want to know. I don't want to know any random stuff out there that, AI can actually do for me. So that has been focused in the industry, and this is a Japanese operator, SoftBank. So they have been kind of driving some of these activities in terms of developing, instead of a large language model, a telecom specific model, just as an example. And then you can go across different people, and you can ask questions like, hey, for this side, what should I do in terms of configuration? Because there are these kind of things. Can you recommend something for me? Or, why is there a performance degradation in that area? What is happening? So for example, there could be an event happening in a football stadium. There are thousands of people, so there is some degradation. But I don't know that happened. But AI can get information from various sources and try to correlate that. And then so all that kind of so the way operators work is all the data that is coming from various cell sites and all, they get fed into a data lake where all the data it's like a database where all the data gets stored. And so you can query that and you can ask questions about it and you can say, hey, what's happening here? Just like a GPT chatbot that you have, you can query that to ask questions about it and it will give you all these type of things related to AI. But I think where I believe things get real challenging is when you're looking at the edge of the network and looking at the wireless environment and looking at compute constrained infrastructure and when there are latency constraints, because not every time I can send something to the cloud. Maybe I'm in a remote location in the middle of nowhere and I have some sensors sensing for forest fires. I'm just giving an example. I was in California for some time. But anyway, so I'm just saying that it's not always possible to send all the data. And there are sometimes privacy issues, security issues. And so sometimes you have to keep the data local. And sometimes there is so much data. I think we were just discussing, somebody mentioned terabytes of data, right? I mean, you have to figure out what to send and how much to send and when to send. And so that's where I think things get real challenging. And I think that's where I think from an IoT standpoint, it makes interesting. So again, I'll correlate this to what I'm doing in my company. Again, as an example, again, I don't want to focus mostly just on my company, but what we are doing at Ennoia is we are building like an open platform for intent-driven network abstraction. So we have not been looking at IoT space directly, but we have been looking at devices at the edge of the network more from a cellular space standpoint. And so what we have built is, what we call as a connect platform. And the idea here is a lot of the devices that sit at the edge of the network. I mean, this could be like, like a self-driving car. This could be like sensors that are there at the edge. This could be like video cameras. And so what happens is, one of the things you will see today in all the devices that are getting built, they will all have an API. And the reason for having an API for programming that device is basically from a test standpoint, because anything you build, you have to test it to make sure it's working. And how do you test it? It has to have some kind of way to communicate. And how do you communicate? You have an API solution. And so what we do is we actually have AI understand these APIs. So, for example, I have something, configure this way, do this way. So what API it calls when you're actually trying to do it. So if you can make your AI actually understand all that. Then we have two types of applications. One we call as chat and test, which we basically use for configuring the system. So for example, it could be like, we saw the talk that's 80 days, for example, to change the frequency band. I don't want to know how to configure that particular device. I just want to tell it, hey. And the example sometimes I use is, if you take a microwave, for example, every microwave is slightly different. You want to cook for 2 minutes, you have to sometimes go figure out which button it is and how it is. It's slightly different, every microwave. So it takes you like roughly 2 minutes to actually figure out, but what if I could talk to the microwave and tell it, hey, microwave, cook this for 2 minutes. And it can be in any language you speak. And it understands and it actually cooks it. So you don't have to understand anything about the microwave. You don't want to know. So all these systems are 1,000 times, 100 times more complex than a microwave. So think about the ease that it would provide in terms of use of the appliance or the equipment. If you had this kind of a natural language which you use to communicate with the device. And so we have one set of configuration Copilot. The other part is the analysis part. So the data that is now coming out of all these devices, it's just raw data. I don't know what it means. So just one second. So what kind of applications and what kind of processing I can do on the data to make sense of the data that a person can understand rather than looking at raw numbers. And I think that's the it's your question.
Yeah, so my understanding here that, you have the voice interface to a, let's say, a microwave. Is that correct? Or I'm wrong?
I'm saying that, I'm just giving that as an
Right
example.
now, you're a touch thing, okay?
Mhm.
So you have a capability where I can just give the command by voice.
I think that is possible. I'm not saying I have it, I'm saying it is possible to do it. I'm saying it is possible to do it.
Given that you said that you're going to be competing all devices and we're already building MCP out, I'm guessing, are you guys going to be implementing MCP with this? And you guys going to be integrating that?
We are looking into MCP. So we're just for people who are not aware of what MCP is what they call model context protocol. So the idea is you have a lot of different types of models and different people. You need to have some language if all these things are going to talk to each other. And people have looked at what is called as different types of AI agents for different models trying to talk to each other. That's where MCP comes from. Okay. So yes, we are looking at that for our planning. Any other questions? Yes.
This is sort of a ill-formed idea, sort of a backup idea right now. I'm trying to make it help. So I understand that you're not interested in using AI for like the content, just like episodic things like what's capital France, those kind of things, what's weather like that. You're interested in like the processes of like how things are working, what basically how the things occur, and that's something they wouldn't be able to tell you it's doing right, like reflexively, I guess it would be, right?
I mean, what I would call it is the models are domain specific. So, for example, I'm working on IoT. I don't need to know anything apart from IoT. So, I mean, if you look at a general large language model, it knows about everything. I mean, it's the same model, whether you want to ask it the capital of France or you want to tell how to book my flight tickets. I mean, all that is the same chatbot, ChatGPT that can provide. Here, what I'm saying is you don't need all that complexity. So when you're sitting at the edge, you're doing something specific. You can optimize the models just to work on that, and that makes it work in a smaller form factor. You don't. It can be done offline, so it's small enough that it can sit on a small compute. And I'll give you some examples as well later on what is feasible. But that's what I'm getting at. I'm saying that you want application-specific models. You don't want generic, large, huge models that can solve world hunger. You want to solve your hunger.
That sort of gets like the question I was going to ask is so given that analysis of the throughput of these processes, right? And you're mentioning terabytes of data. Mm-hmm. So we just had someone speak here, right? I think last month about the data that will be generated when IoT kind of health devices come online. We're just going to massively, exponentially explode everything, right? So what's like, I forget the next level of exabytes is up there. That's like a lot above, right? So my question is,
Zettabytes.
So ultimately, like how, since you're in telecom, like how is that to be managed? When like, what's the next frontier in that? Because these are like enormous things. It's going to be there's already a series of game shifts going on as we're breathing, right? But like doing a game shift about the game shifts and how to process their interactions, right? So do you have thoughts on that?
No, I think
or that's maybe
this problem is it's all a scale problem of scale and time, right? Yeah. So if you look at, for example, so if you look at the way, I can give you an example from the way, the radio networks are built. So typically the data that is coming from a radio, like the signal level and stuff, it's huge because it's sampled at very, very small time. And then you process it and then you extract some information out of it. Now, when you do the transfer, the amount of data that goes down by a factor of 100, for example. Okay. So then it becomes easier, and then you don't have to process that in real time. It becomes to translate basically the data from a real-time system to a non-real-time system, and so that basically shrinks the data before you do that. I mean, if you look at it, I mean, even all the compression you do for your photos on your phone, I mean, everything is always compressed, right? I mean, you store it in JPEG. And so a lot of compression. There are different ways of compressing data and how you actually process data to kind of reduce the compression. So the question I think is, how do you make sure you don't lose the information? Because what is the real value of the information? It's not how it is put, but basically what is the information content, and how do you extract the right amount of information from it?
Okay. And to be clear, I think what you're showing here, right, is more at the higher level. It's extracted outside the device. So the bandwidth, the high speed bands can be down here, where you'll have custom ASICs or custom hardware that can be doing the AI
That's
at a different level. But up here, he's doing more of the configuration, the testing, analysis of data, but you're not doing terabytes or gig, this level.
That's correct. So that's happening in the device itself.
Right, exactly, which will have customized hardware that will keep up at speed to do that. So it's two different worlds. He's at this level of the world. That's whole nother AI world.
Yeah, okay. I have a follow-up question, but
Okay, I think we'll have time towards the end, so we can take it.
Yeah, oh, yeah, yeah.
So again, as we discussed, right, I mean, so where can these kind of co-pilots really help in the IoT space? So I put a couple of thoughts. I mean, you may have more thoughts. So first thing is, proactive alerts or predictive. I mean, we just discussed that in the context of cars. So the second thing is, guided workflows in terms of orchestration and bring up of the system. Now, especially when you deploy IoT devices, I mean, sometimes it's at scale. I mean, I don't want to go in let's say it's a farmland and I'm putting sensors everywhere. Oh, I have to configure this one, it has this IP address, and that one, with that. Can I just tell, hey, you figure it out, and I don't want to deal with it. You tell me where to place it, how to put it, and you take care of it for me. I'll go and physically put that. That's all I'm going. You tell me what to do, I'll do it for you. And especially then if, for example, maybe one sensor is not behaving properly, and you figure out the root cause, why it is actually behaving improperly. Is it the hardware is faulty? Is it not configured properly? What exactly happened there? So that those kind of issue identification and root cause analysis. The other thing is recommendations. Can you tell me, hey, the system is behaving well right now, but I suggest you look into A, B, C, D to kind of optimize the system a little bit better. You could probably do a slightly better than what you're doing. Some kind of recommendations that you should do to improve. For example, I'm using IoT for agriculture. Hey, you need some fertilizer in this area at this time. Maybe we have to improve the yield of some crop. And then some insights into operational status. If I can query, hey, is everything working okay? Tell me the top 10, places that are behaving badly compared to the rest, so that I can maybe look at it. So that type of information. And then a seamless integration across devices. See, again, we took the car example, right? There could be some cameras in the car, there could be some LiDAR in the car, there could be and all of them have data in different formats, so how do you make AI talk to all of them? Yeah, and I think that's where I think you were talking about MCP and stuff like that too. So having this kind of seamless integration using AI agents that can talk to each other. So I think these are the places where AI chatbots can help with the IoT space. So I think we talked about several examples, use cases. We talked about self-driving cars. I mean, we also mentioned healthcare. I think somebody mentioned about the amount of data that healthcare devices will be having. I mean, a lot of interest in AI, like in the manufacturing space, in terms of supply chain, in terms of figuring out the maintenance, logistics, inventory handling. I mean, looking at smart cities in terms of like traffic, power grid monitoring, data analysis, what's happening at different places, and coming up with recommendations and trends that we are seeing, looking at the agriculture space. Again, these are a few example scenarios where I feel there is value of having AI-based techniques. Now, let's talk about some of the challenges. So we talked about all the good things AI can do, but let's talk about the challenges. I think the first challenge is on training the model. Okay, yes.
Right, so the quick question.
Mhm.
So these IoT devices, they are managed by different companies, right? So if it's healthcare,
Mhm.
so there is a United Healthcare may have some devices which it will own and get the data. So let's say for the car sensing, there will be another company, right? So how would you propose, or what is the thought behind it? How would I get access to the data and do something differently? What they do?
Mhm. No, I think this is again the way the whole IoT. By the way, good to see you, Sarvesh. But the way the whole IoT space is working today is everything is domain and application specific.
Right.
So let's take a hospital for example. So whenever I have, let's say I have a lot of devices in the hospital, I have patients, I am collecting a lot of data. Of course, some of the data has to be sanitized before I use it. There are privacy issues, all that needs to be taken care of. And there is random, so the training of the data would be within that hospital. So the data would not go outside. So you actually have to deploy AI within that network. It's like almost like an enterprise AI. So within that enterprise, you have, and it's trained on all the stuff based on the data that is there. So tomorrow there is an issue or a problem, you actually use that. And this is where I think more and more pushing the AI towards the edge becomes more and more important because you don't want all the data to go out. You want to keep the data within that. And the training that you do for healthcare and the training you do for a vehicle is completely different. So again, you have to kind of keep that separate. That answer your question.
Yeah.
Okay. Okay. So coming back to IoT and AI model training. So IoT systems can generate a lot of unstructured data. And we just discussed car as an example. The data could be noisy because there's some wireless component to it, and there could be noise and other aspects that are there. There could be protocol type of data, because there's some signaling going on for communication. To the next protocol type of data, there could be device data in terms of configuration data and operational data and state of the device, health type of data. So for AI to really work well, the recommendation and the output that you would get out of AI depends on how good it has been trained. So it's always a garbage in, garbage out kind of stuff, and that's how when AI first started looking at cats and dogs and stuff, it was making a lot of errors, but then people started generating enough data. Now you can say with 99% confidence that it's going to get you what you want. But I think this is also the interesting part of AI. See, AI is all about probabilities. So it's AI is not good for math equations. So if you're trying to give 3 plus 5 and you want the answer 8, you rather not use AI for that. So, but AI is all about probability distributions, and it's all about how, so when it's generating something or it's recommending something, it comes with some probability. So if it tells you, for example, there's an issue, it will tell you, I think the issue is because of this, with 75% probability. I think it's because of that, it's this percent probability. So it will never give you a concrete answer. It will give you some options. You like the options, you don't like the options, it's up to you to decide. But it will give you some confidence. Okay, I think it is this problem with this kind of guarantee, but you gotta kind of figure out whether you want to use it that way or not. So I think that's where this whole AI piece needs to be looked at. And as I also mentioned, you also need to look at different types of data and combining them, massaging them, making use of them. And finally, the question is that you need to think about is, just give me one. The question that you need to think about is, what happens if AI makes a mistake? Okay, so let's say you ask AI to do something and we do it blindly. How confident are you of taking whatever is recommended and applying it? And can I just blindly take it, or do I need to put some guardrails on it? Like, hey, make sure that your output is within this range, or how critical it is that, okay, even if it gave me wrong input and if I consumed it, how critical it is to my operation. So these are the kind of things that we need to look at. Sorry, go ahead.
First question is, you've got a risk over there as a meter. What's that risk mean?
So this means
That is on the far side.
Yeah, it's too far. That's what I was wondering. But it's close to green, so I don't know what that means.
So what I meant is, this is the picture, but what I really was trying to say here is, you need to evaluate the impact of AI on the outcome. If you make a mistake or if AI makes a mistake, how critical it is to your operations. Is your so for example, I'm using AI to send a rocket to space. I mean, if AI makes a mistake, the rocket is going to explode. Will the rocket explode? Or maybe the rocket going to be off by 5 degrees? I mean, what is the impact of making a wrong decision using AI? I think that's what I was trying to say.
Well, if we're talking about AI could make a mistake about the current LLM models, I'm not, as you said, doing computational stuff, right? So it's not going to be, you don't think it's going to be a problem there, right? I mean,
so again, as I said, it depends on what you're trying to do. I'll give you a good example. Like, if AI is in your data path, let's say again, I'm using it for a telecom network, I'm just giving you, and now people are looking at, okay, can I do some intelligent signal processing with AI to do that? Now, let's say AI said, I think if you change this configuration in this manner, the system is going to work great. But unfortunately, that particular configuration was not well tested because, it generated some configuration that I was not aware of. And then, the network crashed, and tomorrow, there's an outage at large scale. Just yesterday, I think you guys have seen United Airlines had a 3-hour crash. Let's assume that it leads to that kind of an issue. Now, that's a big problem if AI does that. Now, the question is, what can you do to mitigate that? Now, there may be other places where you apply AI, which may not be so sensitive. So, for example, I'm using AI to get some recommendation. I want an image that looks, let's look at how people are using AI today, right? There's all this Ghibli image generation today, like, you're asking AI to make a photo of yourself that you want to put on LinkedIn. Okay, it generated a photo. You didn't like it. You got something, well, I don't know, this is really looking like me or not, but hey, that's fine. If it's not 100% accurate. So I think that's the kind of risk analysis I'm talking about.
Or if it's driving a car and it doesn't think it's a pedestrian, but it is a pedestrian. That's a high risk, right? Versus you don't like your image on LinkedIn.
So another question on data privacy and training. So for example, right now you were discussing about healthcare. Like you cannot get the data out, right? Get the AI to train on that data in their infrastructure. Now, the thing is to even start the deployment, you need to have some training for it, right? If not enough data in that healthcare system, you need like more data. But getting healthcare data is challenging because of the privacy issues. So I think people use a lot of synthetic data to training. But I think because of synthetic data, the hallucinations are increasing even more. The hallucinations like the wrong decision making and all of that. So are there any solutions that
No, so I think the way I think about AI and use it in these kind of systems, and as you correctly mentioned, sometimes you have to start somewhere, right? So the example I usually like to take is like the Roomba robot. So I don't know if many of you may have used the robot, but you put it on the ground for cleaning. The first time it goes, it hits a wall. And it didn't know there was a wall, so it went and hit it. So, but then it learns. It says, okay, there is some object there. Next time I go there, I should not hit. So I think it's not good to assume that it's a one-shot thing that I deploy AI and suddenly everything works. So it's possible. You always need to have plan B with all the AI stuff. So right now you don't have AI anyway. So you continue using your regular stuff as you are using it today. And let AI start introducing AI. It will make some mistakes, make some errors, but don't use that output quite a bit. Wait until it is learning from the mistakes and it has evolved to a certain degree. And at the point where you see it's generating equivalent performance, that's the time you switch. Does that make sense?
Yeah, it does, but I think with healthcare, it's pretty critical, right? Like,
Yeah, so again, as I said, you have to figure out what is the specific problem and how you're using AI to what degree. So,
but as long as it is still a black box, it's still an issue. So we need to probably like create a logic based or like more guardrails or something.
yeah, I'll give you another good example. Again, coming back to the healthcare example. So I recently, because I moved from a company to a startup, I moved to my wife's health insurance plan. And when I moved to my wife's health insurance plan, so typically, when I do my blood tests and stuff, I go to the doctor and then yearly annual checkup. But this time I saw an option. They said, hey, we will send you something to your house. Okay. You prick your blood on your thumb and send us, and you'll go on and put that on a piece of paper, and they give us specific paper, and they ship it back to us. And then we'll analyze it and tell you whatever you are going to go to the doctor and doing it. I'm just giving you as an example. But then, when the result comes back, well, I knew my blood work because I had done it before, and I see it's not 100% matching, it's maybe 90% there. But they put a big disclaimer. This is meant to be an indicative measure. If you really want to get it validated, go to the doctor. So the way I think about AI, this is the way you need to think. There are smart watches which trigger, like for example, you're getting a heart attack, it actually sends a trigger. But that doesn't mean that you're getting a heart attack, but at least you're getting some indication that maybe I need to be a little bit careful what is happening. So I think I would think about it from that angle. So I wouldn't trust it blindly, but it is still helpful.
But just to follow on what she asked you, so from a healthcare standpoint, there's going to be HIPAA issues related to using AI.
There's going to be issues. HIPAA is on the healthcare side. There are issues with every single piece. I think the question is what data you are using and how anonymous can it be? Right now, for example, AI is now reading X-rays. People are looking at X-ray charts, figure out I have, my bone is broken or it is not broken. And AI is doing a very good job in telling that maybe sometimes even better than a doctor can do it sometimes. So the question is, how do you take the data and anonymize it? And I think this is not a problem just in the healthcare industry. This is a global problem with AI. The issue is who is responsible for the quality of the data and who's owning the data. So see, if you make the data publicly available, let's just give you an example. Then let's say all the universities and anybody can contribute to this, like it comes like an open source project. Everybody can contribute to data, but somebody may be giving junk data, somebody may be giving useful data. So who will police the data and who will check and who has the time and effort to do these things? So this is where all the standardization and ecosystem kind of processes come into place, and it has not been easy because who wants to take the first step and who wants to be the guinea pig and who wants to actually start all this stuff, and how are they going to think about themselves? Are they thinking about the overall industry and how much they want to help others? I think all that comes into the discussion. Yes.
Just to answer his question, so you can watch your PI information. So once you watch your PI information, it's still full of knowledge, but the hospital has full of knowledge. It goes to the state entity, like CDC, and that, and that's used and that's publicized, but you just have to watch your PI. So there are guardrails that you can put in to answer that question.
Yeah, as I said, everybody is doing things, but the question is how much. See, for AI to work well, you need good data and then you need bad data, and you need to characterize this. This is how a good data looks like. This is how a bad data looks like. So when I get some new data, I can tell whether it is good or bad. So I think that's where the challenge is in terms of figuring out who is giving the right type of data. Am I getting enough data to make sure I don't go into some of the hallucinations that we're talking about and things like that.
Well, this means that similar to watching for viruses, as new sensors, for instance, in a chain, are integrated into the system and new things come along, you have to guard against false positives, and you have to. Like the training is always going to lag the real world experience of
That's
that
right.
system.
That's right. So I take this as an example again, coming back to the Roomba example I gave, right? So let's say, the Roomba is working fine in this space, tomorrow I got a new chair and I put it there. So it's going to go and hit that.
Yep.
But again, so the question is, okay, when they hit that, it has to learn that, okay, there's something new there, it was not there. So it made a mistake that, that it thought that there was nobody there, but actually turned out that was something new came up. So I think with a lot of these models, I mean, that's the truth, that we got to kind of keep figuring out what is the right interval to actually retrain and how to actually trigger the retraining of the model, because they have new data, or as you mentioned, maybe something new structure has come in or something new has happened, so it has to kind of go and yes.
You mentioned earlier to push more of the compute down to the edge. In a lot of use cases, there's not a lot of power there to actually power the compute. So where do you think that's going to go?
I think, see, it's I would say it is, we like to believe that there is a lot of power in a data center. But the reality you would be seeing, actually, I was just reading some article the other day that Google promised, I think, the US government that they will not consume more than a certain amount of power or something, and they'll actually shut down some compute if necessary. I'm just saying that that has been a pain point, but I think there has been efforts in reducing that, and but you see it more and more that AI is getting towards the edge. I mean, you saw now the Qualcomms of the world are now putting it into phones,
Well,
right?
like
So,
that thing right there.
yeah.
There's not going to be a lot of power to power the compute.
That's correct. So what I'm trying to say is, there's not enough power today to power that compute.
And there's new technologies that are doing things like spike. It depends. It's very application dependent. But there are new technologies like spiking neural networks and that are like a lot. I mean, they're doing AI in very, very low power with different technologies that are for the edge. And there's a whole frontier going on.
Okay, so that's so when you say very, very low power for the edge, so he has this little device here.
Yeah.
You mean low power like that?
Oh yeah.
It's like micro amp.
Yeah, microamps. Because you can get the technology to very sparse models with like spiking neural networks and things like this. They're very, very low power.
Yeah.
So
I think-
almost any process that's going to come out in the future is going to have some kind of NPU in it, some kind of processing circuit. It's
I
just
think
the way
that
it
is
is.
a comment.
Yeah, I mean, to piggyback off of this, what is the major bottleneck then to like, let's say I want to have multi-model on the edge, I want to have voice, I want to have vision, I want to have content.
Multi-modal.
What's the bottleneck then if we have the compute power to do that right now?
No, I think
Cost.
Cost, sure,
no,
sure, but beyond
Yeah,
that, I think.
no, I don't think it's just cost. It's I think right now the industry focus is actually going in the reverse direction. People want to make it more and more powerful, not more and more edge specific, because what they are seeing is they want to do more and more applications and more use cases that they want to do. So I think, you see all because everybody is comparing themselves with others, right? I mean, if you look at, Gemini versus Anthropic versus so all these kind of large language models that OpenAI, all these companies who are building stuff, they all are comparing their large language models. So they want to take more parameters. They're actually going in the bigger and bigger scale. At the same time, there's a lot of research now into how to make chips for AI with low power. You can see a lot of these companies are getting multi-billion-dollar evaluation with nothing, just a proposal in hand. So I think that's one trend that's happening on that side. But I would say that on the IoT side, again, if you give me a few slides, I think I will show you the Raspberry Pi, for example. People are trying to see how to actually make AI work on embedded compute. And as I said, this is where you have to become more and more specific. So the more specific you can make to that application, the smaller footprint you can make for the model. Now the question is, how do you make it specific enough that it will fit into that hardware that you're doing? And then you need to put some smarts on top of it, because you don't want it running all the time, like just like your phone, right? I mean, people have spent a lot of time optimizing the phone to make sure when it's not doing anything, to put sleep modes and low power modes and stuff like that. So here also, I mean, AI, you have to be really careful. I mean, if you are battery limited, I mean, you don't want to be running this all the time, but maybe you run it when I need to at a specific time. Then I run the AI engine to do something.
Yeah, I mean, it's like a heartbeat. You can use very low power circuitry that are just like triggers it, and then it turns on the next thing, which is very low power, but much more power than the trigger. It's all hierarchical. It goes all the way up to data center, which is, megawatts.
So the other thing is, another way of thinking of devices at the edge are often in vehicles, for instance, that are running on their own power source. So they're not adding load to the grid in that mode. You can have devices that are sitting out in the field powered by a solar panel or a small wind generator, and that's not adding any load to the grid either. And so there's a way in which distributing things down to the edge actually helps the load case on the grid.
Okay, actually, since we are talking about compute, I mean, let me just tell you this part. So typically, when we talk about large language models and use, I mean, this is what people use. I mean, they have this huge amount of raw data that they go to feed the LLMs, and sometimes, you need like huge GPUs in data center, depending on whether they're doing fine tuning or regular tuning. But I mean, typically, people assume that big GPUs are available at the data center to actually do this kind of. Now, obviously, this is not going to work for IoT. So I think for IoT, I think what people would like to look at is things like this Raspberry Pi. I think you can see that, for example, if you buy this in Amazon, I think you can get it for $300, and it comes with a Raspberry Pi kit, and it comes with an AI kit, for example, and it can do like image detection and all this stuff. I mean, you can do Google on Amazon right now, and you can find it. And there are GitHub projects for image processing and stuff like that with Raspberry Pi. So I'm just telling you, people are able to do a lot of these things now on very small compute today. And it's amazing, what they're able to do today. And so in terms of, research problems, I think this is where I think the interesting is. The question is, how do I process lots of data in real time with local compute without having to send to the cloud? The other question is, how can I aggregate different types of data? As I mentioned, there could be different types of devices. How can I aggregate different types of data with different volumes? So some data like a camera image may be huge. There may be some sensor that is sensing the tire pressure, that may be, very little information. And the time intervals may also be different. Something may be coming every second, something may be coming every minute, something may be done at every hour. So how do you aggregate all this stuff? And I think the other part that people sometimes who are working on AI fail to recognize is, okay, without AI, there is a system today that is working. Okay, so you need to compare yourself against that system to know. I mean, you better be better than that. Otherwise, why am I spending all this time? Just because AI is cool doesn't mean you go and now start replacing everything that we have already built. So it needs to do some value. And now, the other cheat code people use, in my opinion, is when something doesn't work, the AI is actually good, but the data that you gave it was not good enough. That is why AI is not being operated. So I think, again, those kind of things need to be carefully evaluated so that you don't pass the blame to something else. I mean, maybe it was not a good use case for AI. But again, the question is, how do you quantify this? I think that's really the challenge. And I think we already discussed this availability of data sets. I think there was enough discussion on this part. we also talked about power consumption and how we optimize it. And I think we also talked about HIPAA. And so I think a lot of these items we already brought up today for discussion. Do you have another question?
I'm a little foggy. How does all this connect to what you guys are marketing?
So what we, again, this talk was not meant to sell my company, but I'll answer your question anyway. What we are trying to do is we want to make AI more prevalent towards the edge. One of the devices that people use, like technicians, like things that you're doing, not on the cloud and the data center, but at the edge, how you actually do this. And so we have been working on, for example, small language models like Tiny Llama, these kind of small models that where we train the different devices. So we take the APIs from these devices and we make these devices understand AI. So tomorrow, if I want to use AI to touch that device, I don't need to know anything about the device because I've already trained the model to understand. So I have all these devices and I don't need to read their data sheets. I don't need to read their manuals. I don't need to do anything because I already have an AI agent who has been trained on that. So I just talk to that AI agent and that AI agent understands natural language, just like that microwave example. He knows when I say turn on the microwave for 2 minutes, he knows what 2 minutes are, he knows what turn on means, and there's an API for turning on, and there's an API for 2 minutes. And so he knows how to set it, and then it works. So that's what I was trying. So that's what we are doing.
So what APIs are being used today? Because you say you're looking at some of this like SP.
So it depends on the APIs are all over the place.
Yeah, there's some.
So if you take, I'll tell you some of the popular ones. So the popular ones, for example, if you take any kind of networking gear, so REST APIs are very common. So there's all this request response kind of things, just like a HTTP. I mean, it's like, a REST API. So that's very common. The other APIs that we have seen for instrumentation type of work, there's something called Visa. I think it's called Virtual Instrument System Architecture or something like that. And again, it's very common. And then in the RAN space, in the telecom space, again, 3GPP has defined a lot of protocols and everything. So the messages and all are standardized. So you know the API that we use. And then there's an open RAN version of it, which also has some APIs. So, but the beauty of this whole AI stuff is, I don't care whether it is a well-defined API or not. As long as there's an API and you show me the API manual, that's because I can train it on that. I can adapt it to that specific scenario. So it may not be globally applicable,
Right.
but at least your instrument, your API, I can make it work.
Just to clarify, you are talking to AI agents on devices, right?
That's right.
Okay, so given the fact that Anthropic, OpenAI, as well as Google, they've adopted MCP, or why not use MCP to interface with?
As I said, MCP is something new, so we are still evaluating that. But that definitely is it's a valid approach for AI agents to talk to each other. But the other thing I want to mention is this: when I talk about APIs and integration, see, a lot of the equipment and devices, they may not have any agents right now.
Yeah.
But what they have are APIs, and you can use the API directly. You don't need to wait for them to have this kind of an agent sitting on that device.
Yeah. So you guys aren't in the business of implementing or deploying agents to these devices.
No, because all the devices are made from different companies. And how do I can't control what he's putting in
That's what I was
there.
getting to is you need to work with a lot of different APIs. And
Yeah.
if you want to use MCP, you have to have everyone use MCP. And
That's
that's not
right.
going to happen, at least now.
I guess I thought that they already had agents on devices.
No, so we have known APIs from different devices that we have integrated with in my company.
Yes.
But let's take that offline. I think that's not the purpose of the discussion. But yeah, I think let me just I think it's 7:15. I'm out of time. But let me just summarize. So I think I would argue that AI is enabling next generation of innovation here and in devices. I think there can be some intent-driven approaches using copilots that can benefit here. I think the value here is the people who generally work on AI, like all these people working on Anthropic and cloud and all that, when they are not the people who understand hardware, they don't understand what a router is and what a IoT device is, what a sensor is. They are typically sitting. So this type of approach is enable these kind of people to work with all this hardware without learning all the details. I mean, I don't want to know how to configure that part to a certain frequency band. I just want to tell it, hey, get me that data at this time. And he sent me that's all I care about. I don't want to do anything related to that. So I think that's where I think the value. And I think there's a big set of problems. I think I think this kind of problem has been there for the last 30 years, I would say, in terms of how much stuff to put in hardware, how much stuff to put in software, and this whole hardware software integration. So I think it's the same thing, how much to put on the edge, how much to put on the cloud. But you can see, but one thing is very clear that, I mean, the amount of compute you're able to put has been increasing. I mean, people talk that, the phones today have more compute than mainframes were there 30 years ago. So, I mean, that's how things are evolving. So, I think thank you for the good discussion. I think, as you say, I have only 15 slides, but I think there was so much good discussion.
Let's give him a hand.
Thank you.